Okay, so just to go back quickly, excuse me, just to go back quickly for the benefit of you who will be watching this at home, the first slide is simply vocabulary that you need when we discuss circles. So you may pause the video and copy down the words at your own pace if you did not get them all in class. Okay. We were naming the minor arcs and we came up with what? AD. So the way that you indicate that it's an arc is you write the letters AD and then you put a little like umbrella. Put a little umbrella over them. Okay, so we have AD. What else? CE.
You said AD.
AD.
How are they arcs?
They go from point to point on the circle.
That
AD,
means
we
that.
have AD, we have CE, we have CE, and then finally Good. Okay, so those are my minor arcs.
Oh, you put minor and major.
What?
You put minor and major on one.
Yeah, you
I just thought of that.
AC is a
A, C, D, E are major.
did. They are not.
They are?
They're not.
Oh.
well, they're less than the semicircle.
Less than a semicircle.
Oh.
What is wrong with you?
You're the one that called it out.
Okay.
You can't play with me like that.
Now,
That's nasty.
now to name the semicircles. Now, we have two diameters, okay? So, the semicircle is going to go from one side of the diameter to the other side of the diameter. So what's the problem by saying semicircle DC? Here's D and here's C. What's the problem with saying semicircle DC, Jonathan? O is just the center of the circle. That's actually the name of the circle. This is circle O. What is the problem? What is the problem with saying semicircle DC? No. Jonathan? What? Is what A? Did you hear my question? Okay. Why can't we say semicircle DC? Tyler? So what? Why is that important?
Because when did we like...
Okay. Let me ask you another question. Which semicircle is semicircle DC?
Oh, you can't tell which side is which.
That's right.
Oh. I get it.
This is semicircle DC. And this is semicircle DC.
Oh.
So what you have to do when you're naming semicircles is pick another point. So we have semicircle DAC.
Oh, that makes so much sense now. Yeah.
Semicircle DAC, and then we differentiate that from semicircle DEC. And we also do that. We also have another diameter AE, so we have two more semicircles. One of them is ACE, very good. And ACE and ADE. Okay, please be aware that order does not matter. So I could call this semicircle AD. I could also call it, minor arc AD. I could also call it DA. Same thing with DAC. I could also call it CAD. And yet, but just understand that once you give it one name, you don't, like we wouldn't say there's 8 semicircles. We would say that there's only 4. Okay, now, major arcs are greater than 180 degrees because that's how big a semicircle is. So now, we would start with A. So A, C, all the way around to D. No, just the starting point, the ending point, and a point in the middle. So you could call it AED, or you could call it ACD. And then really, all you have to do is just go around the circle. Yeah.
Wouldn't
This
it be
is
the
easy,
same?
Mr. Spencer.
Wouldn't it be the same as DAC? Like,
DAD as what?
like as ACD?
This is, no, because like DAC,
Yeah,
Like
DAC.
DAC goes-
And then you say,
DAC goes from here to here.
and then you said
ACD goes from here to here.
Okay.
They're two completely different. What you could be thinking of is if you say semicircle DAC is the same as semicircle CAD.
Are there ever going to be circles where there's more than one segment going in?
Like this?
Like, is there going to be one big section?
I know what.
Maybe, maybe not.
Going to the name.
Maybe. Okay, so another one we have is, excuse me. Okay, so we did ACD. So another one we can do is start at point C, CEA.
Why do you always mess with it? People don't write it down.
Why do I what?
How come you don't include like B and B?
Because you don't need to.
Can we?
Because that's just geometry.
Because you just want to write enough so that you can see which one it is that we're talking about. So if the question is, could you call it CDA instead of CEA, the answer is yes. But you don't need to put both points. Excuse me. Are you testing?
Oh no, I didn't know she was
So we don't need to, it's unnecessary, that's why we don't do it. We don't have to. So now if we start at point E, what's a major arc starting from point E? EDC. EDC. And then finally, we start at D. DAE is correct.
That's why I'm not recording.
Does it have to do with this? What?
Harder.
Okay. Alright. Now, we know how many degrees there are in a circle, right? There's 360 degrees. So that measurement doesn't matter. The size of the circle doesn't matter. So, my 360 degrees can be here, or my 360 degrees can be around the outside of the circle. It doesn't matter. So what this arc measure note here says, that the measure of the arc equals the measure of the angle that it is connected with. In other words, if you look at 50 here, 50 is both the angle of measure S, and it's also the measure of angle RT. Okay? So the angle, this angle that you you look at the vocabulary, it's called the central angle. So the measure of the arc is the same as the corresponding central angle. So angle RST is the same as arc RT. And what the rest of it says is that the rest of it, since the whole circle is 360, this whole rest of the part is 360 minus 50, or 310. So this one is 50, and then that whole thing is 310. So that's what that says. Because the circle has to add up to 360.
This is easy, Mr. Spencer.
Okay.
You should make it harder.
All right. So the next thing we want to talk about are what are called adjacent arcs. And just as we learned when we did trigonometry, adjacent means next to. So this is really, really basic and common sense. Is that if you have two adjacent arcs and you know.
There are 4 points, and I know that they're okay. Okay. No, never mind.
Just explain, Mr. Spencer.
What this is saying is that if you want to know how long arc ABC is, you take the measure of arc AB and you add it to the measure of arc BC. There's nothing earth-shattering about this.
I didn't know.
Frankly, it's hardly rocket science. Really? If I have two things next to each other and I add them up, it doesn't equal the sum.
Oh, arcs. Okay.
And adjacent just means two arcs next to each other. They share 1 point. Basically, so it's differentiate this arc.
No, because I thought it was only talking about sections.
No, full circle. All right. Anybody not get this down yet? Okay. So now, this is a very typical problem. You're going to be given a circle with different information, and we want to know the measure of all the arcs. Now, of course, the easiest one is, of course, the one they start us off with. So we know that CD equals 58. Okay, so what I'd like you to do, these are my 6th period, nope, these are 8th period concepts.
And you didn't even play.
Go ahead.
Because the semicircle is 180,
Right,
and 180 minus 58 is
very good, that's perfect. Okay, is there anybody who doesn't understand where she got the 122 from? You didn't understand either, Bill?
Nope.
Okay, Tyler, can you please explain how Anna got 122 here?
Yes, because CA is semicircle, which is 180 minus 58 will be 122.
Oh.
Right, we know that going halfway around the circle is going to be 180 degrees, 360 divided by 2. So we know this whole thing is 180. We already know that this portion of it is 58. So to get this, it's going to be 180 minus what we already know, which is 58, to give us 122. Okay? Bill, you're up next. Pick another arc and tell me its measure, please.
Yeah,
How do you know BA? Can't know BA. We don't know BC yet. Okay, so how long? BC is how big?
33. I can't.
That's 32. Did you say BC is 32? Why is BC 32?
It's given.
Not given.
Oh, because the angle is.
I'm asking Bill how he got 32. Dylan?
Because BOC, because the angle is 32.
Right, we know that if this central angle is 32, that the arc that corresponds to it is going to be the same length. So it's 32. Okay, that leaves us with BA. Joe, how do we find the measure of arc BA? Kiera, I want you to tell me another way to find this one, knowing what you know. Tell me another way we can find the measure of BA. All right, Kiera, can you help her? Gabby. Yeah, Joe told us one way to find BA is to take CA. CA we know is 180. So again, just like we did before, we did 180 minus 32, and that gave us 148. But I'm suggesting to you that there's another way. Right, another way. Okay, Jonathan? That's what Joe did. No. Well, maybe you can. Jack?
Do 122 minus 360.
Not 122. Bill?
Less that.
Okay. You're all dancing around it. We know that the whole circle, I'm not saying that this is the best way to do it. I think Joe's way is the best way to do it. But you know that the entire circle is 360. We know that this one is 122 or 180. We know that these two combined are 180. And we know that this is 32. So you can do 360 minus 212 or minus 180 and then minus, is that what you were saying? Okay. I didn't understand. Gives you 148. Now again, to me that's more work than necessary. To me this is much easier, but you can see there's always more than one way to get the correct answer. Okay, does anybody have any questions?
How did you get 212?
I know that the semicircle is 180.
Right.
180 plus 32.
Okay.
Okay, if there are no other questions, please do this one.